Okay, if you're going to use L'Hopital's rule, again, we start by applying the limit just as we always have. Let x be 1, plug in, see what happens. If you get 0 over 0 back, then we're allowed to use this rule. And in this case, we already know we're getting 0 over 0 back. So how I apply L'Hopital's rule. I continue to apply the limit as x approaches 1. But now what I'm going to do is I'm going to take the derivative of the numerator expression. So derivative of x squared minus x would be 2x minus 1. And I'm going to take the derivative of the denominator expression, 2x. Right? That's what the rule states to do. Take the derivative of the top, take the derivative of the bottom. Now apply the limit to the new expression we've got here. If I apply the limit at this point, 1 gets inserted for the x's. I've got 2 times 1 minus 1 over 2 times 1. Not that I need to write this step. But doing that substitution and calculating this out, I get 1/2 back as my answer. All right, so just like on the last one, we know in this case x is approaching 0, so we're taking 0 and we're plugging in. We first got to make sure that when we plug in 0 initially here, we've got 0 over 0 back. So obviously to get 0 on the top, we've got 3 times 0 here, which is 0. You're taking the sign of 0. You got to remember what the sign of 0 is. Well, let's see. This is where 0 is, right? This is my terminal point. Sign goes with y, so sign of 0 is 0. We do get 0 over 0 to start, meaning we can use L'Hopital's rule. So applying L'Hopital's rule, we have the limit as x approaches 0. Applied to the derivative of the numerator portion here. So derivative of x would just be 1 over the derivative of the denominator part. So taking our derivative with what we know about trig functions, we start with sine. We know sine goes with cosine, right? We know this argument stays the same. But then we also appreciate about the chain rule, we got to tack on the derivative of that argument. So derivative of 3x would be 3. We've got our derivative of the top, we've got our derivative of the bottom. We now resubstitute 0 in for x. When we do that, we've got 1 over, well, it'll be 3 times the cosine of 3 times 0, so it'll be the cosine of 0, right? The cosine of 0, by definition with the unit circle here, cosine goes with x, so that's going to be 1. You've got 1 over 3 times 1. Answer is 1/3. Okay, so this one is going to provide a little more of a challenge. But we start this problem the same way we did the previous two. You take 0, you plug in for x. Now, obviously down here, we get 0 back, right? The question is, do we get 0 back on top? If we do, you got 0 over 0, you can use L'Hopital's rule. So if I take 0, I plug in up here, I've got the secant squared of 0. Could also write this as the secant of 0 squared, right? It means the same thing. The question is, what's the secant of 0? Here I am back at 0, right? Here's my key terminal point. Yep, it's going to be 1 because reciprocal of secant is cosine, and cosine be 1. So 1 squared, get 1 back here, minus 1, we've got 0 over 0. We can use L'Hopital's rule. So this is going to equal, the limit as x approaches 0. Applying L'Hopital's rule, take the derivative of the numerator expression. Since this is the secant of x squared, we're using a chain rule here. Bring down the 2. You've got secant of x. New power is 1, right? But you have to tack on the derivative of that's secant of x. So derivative of the secant of x is secant of x tangent of x. That completes the derivative for this part. The minus 1 part goes to 0. Denominator, a lot easier to take the derivative of. That's just 6x. Now, at this stage in the game, we're taking 0. We're plugging back in for x, right? Obviously, down here, you're getting 0 back, which that's going to create a problem. But if you plug in 0 to the top, well, let's see what we get. We talked about the secant of 0 being 1, so this would be 1, this would be 1. What's the tangent of 0? It's going to be 0, right? Because by definition, tangent would be y over x. It's going to be 0 over 1, so this will be 0. That means we get 0 over 0 again. That means we get to use L'Hopital's rule again. So we're going to continue to apply the limit here. Because we got 0 over 0 back again, we take the derivative again. Taking the derivative of the numerator expression. Look out. Here we go. Understand, as I take the derivative up here, it would probably make sense to combine these, right? Multiply those together, make that the secant of x squared, right? That way, what you can do when you take this derivative is you can have this piece multiplied to this piece. You have a product rule. So I need to simplify it just a little bit before I move on. But doing that simplification, using the product rule at this point, you take the derivative of this first part. Using your chain rule, you bring the 2 down, multiply the 2 in front, you got 4. You got the secant of x raised to, subtract 1 from the power, so power is 1. You got to take the derivative of the inside, so that's secant of x, tangent of x. And all I've done so far is take the derivative of this piece. Okay, now, continuing the product rule, we have to tack on the second piece as is, add that to this first part as is, but multiply to the derivative of the second part. So the second part is tangent. Squeezing that in over here, the derivative would be, for tangent of x, secant squared of x. It's a busy little problem. That's the derivative of the top. Still got to take a derivative of the bottom. Thankfully, that's easy. Derivative of the bottom is just 6. So now that we've taken derivative of the top, derivative of the bottom, substitute 0 in for x. We substitute 0 in for x. We've applied the limit. Limit notation goes away. Here, you guys do the top, I'll do the bottom. I got 6 on the bottom. You guys got the top yet? No? All right. I'll help you out. So, secant of 0. We've talked about this now. Secant of 0 is 1, right? So this is going to be 1. This is going to be 1. Tangent of 0. This is going to be 0. Okay, over here you've got secant of 0 squared. That's going to be 1. This is the same thing. That's going to be 1. What's left on top? 2, right? Because all this multiplied out gives you 0. All this multiplied out gives you 2. So answer is 1/3.